Imagine plunging into the darkest, most mysterious corners of the universe. What do you think you'd find there? Would you survive the journey? Yes, we're talking about black holes, those cosmic phenomena that have been the subject of intrigue, fear, and fascination for centuries. Let's begin by understanding what black holes are. Simply put, they are regions of space-time where gravity is so strong that nothing, absolutely nothing, not even particles or electromagnetic radiation such as light, can escape its pull. They are the ultimate cosmic quicksand from which there is no return. Now you may wonder, how do these black holes form? The birth of a black hole lies in the death of a star. Not just any star, mind you, but a massive one. When a star significantly larger than our Sun depletes its nuclear fuel, it can no longer sustain itself against its own gravity. The core of the star collapses under this gravitational force, resulting in a supernova or a stellar explosion. What remains is a dense core, so dense that it warps space-time around it, creating a black hole. These mysterious entities are not just empty space, but a great amount of matter packed into a very small area. Think of a star 10 times more massive than the Sun squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing can escape. And what's more, black holes are invisible. They don't emit light or radiation that we can detect with our current technology. We know they exist because of the effect they have on the matter and light around them. So, now that we know what black holes are and how they form, let's dive into the really interesting part. Could you survive inside one? But before we jump into that, it's important to understand the forces at play when we talk about black holes. It's not just about gravity, but also about time, space, and the very fabric of our universe. So buckle up as we journey into the unknown. As we approach a black hole, the first thing that we would encounter is its unimaginably strong gravitational pull. Now let's delve into the science behind this. Imagine you're falling feet first into a black hole. The pull of gravity at your feet is so much stronger than at your head that you start to stretch out, sort of like a piece of spaghetti. This is what we call spaghettification. It's a real word, I promise. And it's as terrifying as it sounds. You see, the closer you get to a black hole, the stronger the gravitational pull becomes. And here's the kicker. It doesn't increase uniformly. Instead, it grows exponentially the closer you get. The difference in the gravitational pull between your head and your feet becomes so great that you're stretched vertically while being compressed horizontally. So what would this do to a human body, you ask? Well, remember that spaghettification we talked about? Your body would be stretched and distorted until you're a long, thin strand of human spaghetti. Not exactly a pleasant thought, is it? And it's not just your body that would be affected. Even the atoms that make up your body would be torn apart. You see, the gravitational pull of a black hole is so strong that it can overcome the electromagnetic forces that hold atoms together. This means that your atoms would be stretched and distorted, just like your body. But don't think that you'd be conscious through all of this. The human body simply isn't built to withstand such forces. Before you even got close to the black hole, you'd be unconscious due to the intense gravitational pull. But let's not forget about time. Yes, time itself is warped by the intense gravity of a black hole. As you fall in, time would appear to slow down for you. But for an outside observer, it would seem as though you've frozen in time at the edge of the black hole, stretched out into a long, thin strand. If you thought that was the worst of it, brace yourselves. The journey has just begun. Crossing the event horizon of a black hole would be like stepping into a realm beyond the known universe. Imagine a boundary, a point of no return where everything we understand about our world distorts, bends, and breaks. This frontier, my friends, is the event horizon of a black hole. It's the line that once crossed, there's no coming back. Not even light, the fastest thing in the universe, can escape its grasps. But what happens as we approach this event horizon? From a distance, a black hole would appear as a dark sphere, an absence of light and matter. But as we get closer, the laws of physics as we know them start to waver. It's a weird and wonderful dance of time and space, a cosmic ballet, if you will. The event horizon isn't a solid surface or a wall in space. It's an invisible boundary, a sphere of influence around the black hole. Within this sphere, all paths lead to the black hole. There's no other direction to go. Now let's dive into the strange world of space-time distortion. As you approach the event horizon, time would seem to slow down, a phenomenon known as time dilation. From an outsider's perspective, it would appear as if time has stopped for you. But for you, time would be passing normally. And what about space? It would be so severely distorted that what was once forward now leads you downwards towards the black hole. It's like the universe has turned inside out, and you're at the heart of this cosmic inversion. This is the event horizon, the point of no return. It's where time and space as we know it distort beyond recognition. It's the doorway to the unknown, the threshold to a world that defies our understanding of reality. So what lies beyond this horizon? What happens when we cross this boundary and plunge into the abyss of the black hole? Let's move on to the heart of the black hole, the most mysterious part, the singularity. At the very center of a black hole, we find what is known as the singularity. A term that sounds almost mystical, doesn't it? But in the realm of astrophysics, it refers to something quite tangible, yet mind-bendingly complex. You see, the singularity isn't just any point in space. It's a point where matter is thought to be infinitely dense. Imagine all the mass of a star, perhaps many times the size of our sun, compressed into an infinitely small point. That's a singularity, but here's the twist. Not only is the singularity infinitely dense, but the curvature of space-time is also infinite at this point. This means that here at the very heart of a black hole, space and time as we know them cease to exist. The laws of physics, which guide our understanding of the universe, seem to break down. Now you may be wondering, if our current understanding of physics can't fully explain what happens at the singularity, how do we even know it exists? Well, the existence of singularities is a prediction of Einstein's general theory of relativity, which has been confirmed by numerous experiments and observations. However, the theory of relativity is a classical theory, meaning it doesn't take into account quantum mechanics, the physics of the incredibly small. And at the singularity, where everything is infinitely small and dense, quantum effects are likely to be significant. This is why we need a theory of quantum gravity to fully understand what's happening. Currently, we don't have a complete theory of quantum gravity, so the singularity remains a mystery, a place where our current understanding of the universe ends and something entirely new and unknown begins. But don't let this uncertainty frighten you. Instead, let it inspire you. After all, the universe is full of mysteries waiting to be unraveled, and who knows what incredible discoveries await us in the future. So, we've journeyed to the heart of a black hole, but the biggest question remains: would we survive? Could a human survive this journey to and inside a black hole? Chances are, even with the most advanced technology at our disposal, the answer would be a resounding no. Let's peel back the layers of this cosmic mystery and dig into the reasons why. Our current understanding of physics, based on Einstein's theory of general relativity, suggests that the moment you cross the event horizon of a black hole, your fate is sealed. The gravitational force is so intense that it would stretch you out like spaghetti in a process whimsically known as spaghettification. Sounds charming, doesn't it? But wait, there's more. As you inch closer to the singularity, the very core of the black hole, the gravitational pull would increase exponentially. By the time you reach the singularity, the gravitational force would be infinite. Yes, you heard that right, infinite. With such extreme conditions, physical survival seems next to impossible. But let's not let our imaginations be constrained by the laws of physics as we know them. There are speculative theories out there that challenge this grim outlook. Some scientists suggest that black holes could be gateways to other universes or dimensions. Imagine that, a cosmic shortcut through space-time. However, these theories are just that, theories. They're based on quantum mechanics, a branch of physics that's notoriously difficult to reconcile with general relativity. It's like trying to fit a square peg into a round hole. Plus, the conditions inside a black hole are so extreme that our current understanding of physics might just go out the window. So where does that leave us? Well, in a state of wonderful uncertainty. The truth is, unless we one day develop the technology to safely explore black holes, these questions will remain in the realm of theory. But isn't that what makes them so fascinating?